Let's finish our discussion on graph representation with comparison between adjacency list and adjacency matrix representations. However, first let me introduce new terms which is going to helpful for our discussion. Consider the two simple graphs below. Now each of these graphs have 6 vertices. So since this is a simple graph, maximum number of edges that can be included in any of these graphs is 15. Now on the left side one, we have 14 edges, which is very close to maximum allowed edge count for this simple graph. If a graph has number of edges which is very close to allowed maximum number of edges, we refer such a graph as a dense graph. So the graph in the left side in this slide represent a dense graph. However, on the left side one, we have very less amount of edges than the allowed maximum one. So this kind of graph we refer to as a sparse graph. With these terms in our bag, let's move on to our comparison. Adjacency matrix implementation is more suitable for dense graph. This is because regardless of the edge count, we are going to allocate memory for all possible connection or edges in our 2D array. Therefore, adjacency matrix representation is more suitable for dense graph. On the other hand, adjacency list representation is suitable for sparse graph because we are only storing vertex pointers and the pointers to the adjacency vertices in our adjacency list. Adjacency matrix representation take only constant amount of time to add or delete edge. Since to add or delete a particular edge, we just need to set particular slot for a particular weight or a integer type max. On the other hand, to delete the edge from adjacency list, you have to first go through our vertex list and find the particular vertex, and then go through that particular vertex adjacency list and find the vertex pointer which correspond to the edge and then remove it from the particular vertex adjacency list. Due to the same reason as for first point, adjacency matrix implementation has the space complexity of V square. But on the other hand, adjacency list representation has the space complexity of VE because we are just storing pointer to the vertex pointers and the adjacency vertices. Now, depending on this comparison, we can conclude that if our algorithms need to find whether the particular edge exists or not quickly, we need to go for adjacency metric kind of representation. Otherwise, we can stay with adjacency list representation. So that's it for this video. Thank you.